Perfect competition, revenues, and profit max. One of the things you should be aware of is all of the cost curves that we looked at before are going to be pretty much the same for all the firms, whether you're a perfectly competitive small business or a monopoly. So if all the cost curves are the same, what's going to be different? The difference between a small mom and pop pizza shop and some huge company, maybe even a monopoly, is not in the cost curves. It's not in the shape of the cost curves. It's in the revenues. So let's talk about the most competitive type of market, and that's called perfect competition. Sometimes it'll be referred to as pure competition. There's certain characteristics of a perfectly competitive firm. 1, perfectly competitive firms are price takers. Whatever the price in the market is the price they get for their output. If you set your price, you're no longer in perfect competition. So any place where you go where there's a price being set, you're not talking about perfect competition. 2, you must have an extremely large number of firms. If you only have 2 or 3 firms, that's not perfect competition. 3, you must have a homogeneous product. That's a fancy way of saying all of the products are exactly the same. If all of the products are exactly the same, you might be perfect competition. So a great example of perfectly competitive industry would be something like agriculture. All corn is relatively the same. That's what we mean by homogeneous product. You must have easy entry and exit. What is easy entry and exit? It must be easy to get into the industry and easy to get out of the industry. It must be easy to start a firm or to end a firm. Finally, you must have good information for both the buyers and sellers. So everyone in the industry has a pretty good idea of what's going on. These are the characteristics for perfect competition. Not many industries actually meet these characteristics for perfect competition. So for example, my favorite product, pizza, is not perfect competition. Pizza Hut pizza and a local mom and pop pizza are not the same thing. Therefore, it's not perfect competition. They're not price takers either. Are they it's not easy. Well, it is easy to get into the pizza market, and most people have good information, but without having a homogeneous product and without them being price takers, you're no longer talking about perfect competition. Good example of perfect competition would be something like agriculture. It's easy to get into producing corn. If you're a farmer, you just stop producing wheat, start producing corn, and it's easy to get out. Homogeneous product, all corn's the same. Price takers, whatever's on the Chicago Mercantile Exchange, that's the price you take. All of those characteristics are really met when you're talking about a agricultural firm. It is pretty close to what you're going to have with perfect competition. Not much else is. If you're a perfectly competitive firm, your total revenue is simply the amount of the product you're producing times the price that you're selling it for. So a perfectly competitive firm can sell 1 unit of output, let's say corn, 1 bushel for $20. Second bushel will sell for $20, so you have a total of $40. Third bushel brings it to $60. Fourth bushel brings it to $80. Total revenue is simply the quantity sold times the price. Profit is going to be the total revenue subtracting out the total costs. So we've talked about total costs before. The profit is now the total revenues that you make from selling your output, subtracting out the total costs. Marginal revenue is the change in total revenue due to a change in the quantity sold. So marginal revenue you can think of as how much extra money do I get for each additional unit I sell. Well, if I'm a price taker, every time I sell 1 more unit, I get the price. So if I'm selling corn, I sell the first unit, I get $20. I sell the second unit, I get another $20. I sell the third unit, I get another $20. So in other words, for perfect competition, my marginal revenue is going to be the same as my price. The profit maximization rule. I am going to continue to operate up until my marginal revenue is equal to my marginal cost. So you can think about it this way. If I can sell every single unit of pizza, even though it's not perfect competition, for $5, if I can produce an extra unit for $1, should I? Well, I can produce it for $1, sell it for $5, makes me better off. If I can produce it for $2, sell it for $5, I'm better off. $3. Sell it for $5, I'm better off. $4, $4.50, $4.70, $4.99. So I'm going to keep producing extra units as long as the marginal cost is just slightly less than the marginal revenue. So the best way of saying it is you continue to operate up until marginal revenue equals marginal cost. Let's take a look at a numerical example. It might make it a little easier to see what's going on. So let's take a look at the costs functions we've seen before, and now let's add in our total revenue, our profit, and our marginal revenue, which also happens to be our price, and the demand that perfectly competitive firm faces, as well as the average revenue that that perfectly competitive firm faces. You can see the total revenue in this column, the marginal revenue in this column, and the profits in this column. We get the profit by taking our total revenue and subtracting out our total cost. So if we produce 0 units of output, notice that our profit is negative 100. Why is that? Because if we're not producing anything, we still have to cover our fixed costs. We have to cover the costs of the pizza oven and all of those other costs that we entail that are fixed. If I produce 15 units of output, which is associated with 1 unit of labor, my total costs go to 110, and my total revenue are the 15 units of output times the price of $5. So I have $75 in total revenue. So my total revenue minus my total costs leaves me with a loss of $35. The next time down, 2 units of labor, I produce 34 quantity of output. My total cost is 120. My total revenue is 170. 170 minus 120 is my total profits of 50. Now you can do this for each and every single combination of quantity and price, which is associated with those different quantities of labor we had before, and you get the total profit. Notice that our profit is maximized at 60 units of output and 62 units of output. But notice also that our profit is maximized where marginal revenue equals marginal cost, which is right here. Let's look at it graphically. Our total cost curve looks something like this from the cost curves we looked at prior, and our total revenue curve is simply going to be a straight line going out from the origin. If we look here, we could operate at this point, but at this point, where I'm looking at, the total costs are greater than total revenues. At that point, I would be making a loss. I could operate over here. Once again, at this point, total cost is greater than total revenue. I would be making a loss. On the other hand, if I operate between these 2 points, this point here and this point here, I'm making a profit. But ultimately, I don't want to just make a profit. I want to make a profit as large as possible. And that's going to occur somewhere around here. How can we figure that out? It's much easier to figure it out by looking at the marginal cost curve and the marginal revenue curve. So let's do that. Our price for the perfectly competitive firm is going to be equal to our marginal revenue. It is also going to be equal to our average revenue. What does that mean? It means that this flat line set at the price tells us the revenues for this firm on average. Now, we can easily see where that occurs. It's where marginal cost crosses marginal revenue. At that point, we are profit maximizing. This point is known as Q star. We're going to use this to figure out exactly how much profits a firms are going to make in another video.